So the title of our presentation is Bananas May Not Be as Good as You Think They Are. So that's basically because our presentation is all about potassium, and we normally associate potassium with bananas. So like that, many fruits and vegetables are known to be high in potassium, beneficial to the body. However, too much or too little can also be harmful, and an excessive amount can actually cause health problems. So we'll talk about that in our presentation. An overview of this, so we hope that by the end of our presentation, you'll know a little bit more about potassium in general as the element and how it functions in the body. We hope that you'll learn more about the causes of hypo and hyperkalemia and how the imbalances of potassium affect the body. That you will be aware of the two drugs that are used to treat these two problems, and that you can compare how the different amounts of potassium vary amongst different groups of people in terms of their diet, and that might be a more applicable part of our presentation. So what is potassium? Potassium is an alkali metal. It is a chemical element with the symbol K and atomic number 19. We can see from this Bohr diagram here that it has one valence electron, and we can see that from the electron configuration as well. That one valence electron is actually what classifies it as an alkali metal, and that makes it a highly reactive metal. Because this electron can be easily removed to produce an cation, it'll almost never, because it's so highly reactive, it'll never occur freely in nature. Humphrey Davy, the English chemist, actually used electrolysis to dissociate potassium from other elements in the compound, and this is a pure version of the compound of potassium, So some more about potassium. Because it's so highly reactive, it's stored in oil or kerosene. An interesting thing about it is that it reacts violently with water. So if you look at the stoichiometry in this equation, when potassium solid is added to water, it produces potassium hydroxide and hydrogen gas. And the heat of this reaction is actually so high that it can actually ignite the hydrogen on fire, and you get this explosive thing. And this video actually has the reaction. It's a really interesting video. Also, potassium functions as a heat transfer medium, basically meaning that the material can pick up heat in one place and carry it along to another place. And this is used in nuclear power plants. So what is the importance of potassium in the body? Fluid balance is one of the biggest things. Concentration of the electrolytes potassium and sodium affect the amount of water in the intracellular fluid, so inside the cell, and the extracellular fluid outside the cell. And this determines osmolality, which is basically the flow of water in and out of the cell. So when you have unequal osmolality, water will move to equalize the concentrations of the electrolytes, and this can cause the cell to shrink, swell up, or burst. So good fluid balance is best for optimal health. Poor fluid balance can cause dehydration, and it can affect heart and your kidneys. So that's why when you sweat, electrolytes are lost, and it's important to replenish your electrolytes. So another important thing, nerve signals. How does this associate itself with potassium? Well, when sodium ions are moving into the cell, potassium ions are moving out of the cell. This causes a lot of voltage cell changes, and these voltage changes activate a nerve impulse or an action potential. And these nerve impulses travel between the brain and body, and they help regulate muscle contractions, heartbeat, reflexes, and a bunch of other body functions. So this diagram here is really helpful in showing us where the ratio of which the ions are moving, and also which ones are moving into and out of the cell. So muscle contractions, this goes along with the other one. The other side, when you have a change in the potassium levels in your blood, this will affect nerve signals in the nervous system and weaken muscle contractions. So when potassium moves in and out of the cells, it's important to maintain regular heartbeat. And when the levels of potassium are too high, the heart will become dilated and flaccid, and this will weaken contractions, and you'll get an abnormal heartbeat. Abnormal heartbeat is bad because if you have an abnormal heartbeat, you can't pump blood to the brain, organs, and muscles, and this causes a lot of problems such as stroke and things like that. So healthy potassium intake can help reduce or lower your risk of high blood pressure, strokes, osteoporosis, kidney stones, and water retention. And this infographic here is really useful for understanding how a healthy level of potassium in your diet can help reduce these things. So how exactly is potassium regulated? This is an example of the diagram of the sodium-potassium pump. And sodium goes out, potassium goes in. 3 sodium ions actually from the inside of the cell attach itself with a ATP molecule, and they'll go out, but that takes energy. So the energy comes from the ATP being using hydrolysis. It becomes ADP. The phosphorylation of the protein actually causes a conformational change in the protein, and then the potassium can bind to the protein and come inside the cell. And then this process just repeats over and over again. So what does ATP do exactly? Well, ATP provides the energy necessary for ions to go against a concentration gradient, because that actually takes energy. Ions want to move with the concentration gradient, not against it. So this active transport needs energy, and that energy actually comes from ATP losing one phosphate, and this breakage of the bonds releases energy. So that's the hydrolysis reaction. So finally, we have voltage change. And what is voltage change? Basically, what happens is a bunch of sodium will come in, and then this will cause the inside of the cell to be depolarized. So there's a lot of positive charges in the cell. So when the sodium gates close, finally the potassium gates will open, and now all of this positive charge will exit the cell, and then you'll have repolarization. And actually, this potassium channels will stay open for longer, so you'll get hyperpolarization, and finally that'll come back to resting potential. And this is important because these voltage changes based on the influx and exiting of these ions into and out of the cell causes the voltage change which is needed for the nerve impulses.
Since it is one of the most abundant intracellular cations. When potassium is found in excess or deficiency in human cells, disease occurs that can cause heavy damage to one's body and even death due to cardiac issues. Organ systems can be affected by K+ imbalances, like cardiovascular due to potassium's role in electric potentials that work the heart, musculoskeletal due to similar reasoning, and urinary due to the kidney's role in regulating potassium amounts in the body. Sodium-potassium pumps, as we explained before, factor heavily in potassium's function in the body and can cause issues when improper potassium amounts are present. Having a potassium deficiency is much more common than having an excess of potassium, although it is just as dangerous. Having hypokalemia is when your blood K+ levels drop below a certain level, 3.5 milliequivalents per liter to be exact. This is commonly a result of not eating enough potassium, since that's the major way humans obtain the ion. Also, excess electrolyte loss through things like vomiting and sweating can cause a deficiency. Symptoms are mostly related to cardiac muscle and the heart's electrical system, as hypokalemia increases the resting potential across muscle membrane. Anything when in excess is typically bad, especially in the case of potassium. One becomes hyperkalemic once the blood potassium level rises too high, which can be the result of causes like kidney impairment, eating an unreasonable amount of potassium, or the ever-rare shift of potassium from inside to outside the cell, as a result of osmolarity issues. This can cause huge issues with polarization, which is done by the potassium ion, which can result in mostly cardiac-related issues like heart attacks, causing even death. Excesses also create an osmotic pressure, which prevents the movement of potassium across the cell membrane.
One commonly used prescription drug for preventing or treating hypokalemia is potassium chloride. There are various brands of this drug, and it comes in many dosage forms, both immediate and extended-release tablets, extended-release capsules, and injectable solution. Potassium chloride is classified as an electrolyte, which dissolves completely into cations and anions once in solution. Potassium chloride is classified as an electrolyte drug because it is a soluble salt, and once it dissolves in water, it will ionize into potassium cations and chloride anions. Therefore, potassium chloride is usually advised to be taken with a lot of water or juice, so that it will dissolve in the body and produce a lot of potassium ions to increase the body's potassium level. For hypokalemia prevention, people are advised to take 20 milliequivalents of potassium chloride. Through the use of stoichiometry, we can calculate a person's potassium intake from taking 20 milliequivalents of potassium chloride. Since 1 milliequivalent is equal to 1 millimole, and 1 millimole of potassium chloride consists of 1 millimole potassium, we know that we have 20 millimoles of potassium and can find the amount of potassium in milligrams by multiplying the 20 millimoles of potassium by its molar mass, 39.08 milligrams per millimole, which gives us 781.8 milligrams of potassium. Hence, by taking a 20 milliequivalent dosage of potassium chloride, a person would intake 781.8 milligrams of potassium. Using the same method, we can calculate the amount of potassium a person would need for hypokalemia treatment. Since the dose for treating hypokalemia is usually 40 to 100 milliequivalents of potassium chloride, we can determine that it would equate to taking 1,563.2 to 3,908 milligrams of potassium through the use of stoichiometry. As mentioned earlier, hyperkalemia is caused by an excess of potassium in the body. One prescription drug used to treat hyperkalemia is Patiromer, also known by its brand name Veltassa. Veltassa is only available in oral solution dosage form. It is classified as a potassium binder as it decreases the body's potassium levels by allowing a lot of potassium in the body to bind to it. The active ingredient that enables potassium to bind to the drug is Patiromer sorbitase calcium. Patiromer sorbitase calcium consists of Patiromer, which is a non-absorbed binding polymer binding to a calcium sorbitase counterion. The Patiromer anion is composed of a long polymeric network that consists of a lot of carboxylic acid functional groups. The carboxylic acid functional groups bind to the polymer through dehydration synthesis, which causes the functional group to lose a hydrogen, giving it a negative charge. The negative charge on the polymer allows the potassium ions in the body to bind to the polymer, and since the polymer is really long, it has a lot of carboxylic functional groups and thus allows a large amount of potassium ions to bind to the polymeric network. Finally, since the Patiromer polymer is insoluble, it is direct release from the body through excretion, along with the potassium cations that bind to it.
And potassium. Note how the ever-popular banana, known as the staple potassium, actually does not have as much potassium as expected, while foods like potatoes are much richer in potassium. The human body requires ingestion of K+ ions in order to maintain homeostasis and intracellular osmolarity, which keeps the fluid and ion concentrations where they should be. The recommended amount of potassium one should ingest daily varies. However, the consensus is around 3,500 to 4,700 milligrams, depending on what country you're abiding by. Some people, however, require more potassium due to circumstances like excessive sweating seen in athletes, African Americans who suffer from salt sensitivity, and those who suffer from conditions like kidney stones. Conversely, some require less potassium, such as people with kidney disease and elderly people due to their reduced kidney function, which results in the inability to filter K+ ions out of their bloodstream, leading to a buildup and overconcentration of K+ cations in one's cells. In summary, potassium is one mineral you cannot go without, as it is required for many bodily functions. Potassium ions generate electric potentials required for various processes. Imbalances of the electrolyte can be excessively harmful, resulting in pathology and even death. Luckily, drugs like potassium chloride and Patiromer can be used to treat the deficiency and excesses of potassium. In conclusion, potassium ions are vital for one's cells and body and their functions, and imbalances can lead to hypokalemia and hyperkalemia. However, drugs can be used to treat these imbalances. The amount of potassium needed from person to person varies based on many internal and external factors, but regardless, the potassium ion is one necessary for homeostasis and maintenance of the human body. And here are our sources. Thank you.